Hello everyone, I am Kiran Kumar Sharma, PGT Mathematics from DAV Senior Secondary Public School, Barmana. Today, I will explain you some common errors done by students in mathematics. Different types of errors done by students: careless error, calculation error or computational error, and conceptual error. So I will explain you some common errors with correction, some of the example from +2 class. Our first topic is a relation and function. So here is the question that let A equal to 1 to 3, check whether this relation is symmetric or not. So what happened? Students simply, they know the definition of symmetry, that if A comma B belongs to R implies B comma A belongs to R. So say they all see that here 1 comma 2 belongs to R, implies 2 comma 1 belongs to R. So it is symmetric. So what is the correction here? They never see that 1 comma 3 also belongs to R, and they forget to check this. Another question: R is 1 comma 1, 1 comma 2, and 2 comma 1. Is it transitive or not? So generally what students do, they simply see 1 comma 2 belongs to R, 2 comma 1 also belongs to R, and this implies AB belongs to R, BC belongs to R, AC. AC means 1 comma 1 belongs to R. They also see here 1 comma 1. So their answer is that this relation is transitive. Again, what is the correction here? So students forget to see that 2 comma 1 belongs to R and 1 comma 2 also belongs to R. Means if 2 comma 1 belongs to R, 1 comma 2 belongs to R, then for transitivity 2 comma 2 must be there, but 2 comma 2 not belongs to R, so this relation is not transitive. But students generally write that this relation is transitive. So you can see there. Next, in relation and function, here is one more example. A set given, R is defined, A comma B such that mod of A minus B is even, is an equivalence relation. So generally what the common error students do, students forget to write plus minus while proving the transitivity. Transitivity means when mod of A minus B is even and mod of B minus C is even, students never write plus minus. They simply write A minus B equal to 2K. So it means here is plus minus 2K1 and plus minus 2K2, then plus minus is common, then mod of A minus C becomes this. So this one is the again common error. Next, from inverse trigonometric function, see this error, cos inverse minus 1 by 2. Students simply see the value of 1 by 2. That cos pi by 3 is 1 by 2, and they simply use cos inverse minus 1 by 2 is minus pi by 3. So what is the correction here? Because principal value of cos inverse x is, what is the principal value branch? That is 0 to pi. So it means student never keep this thing in mind. They simply use the shortcut and write the simple answer. So student must be advised to remember the principal value branch first of all to do the simplification in especially inverse trigonometric function. So cos inverse minus theta, that is pi minus cos inverse theta. So now pi minus 1 by 2 is the value of pi by 3. So pi minus pi by 3, that is 2 pi by 3 is the right answer. Now see the error in determinant. Common error. Finding the adjoint of a matrix. Student find cofactor without taking proper sign. Student don't take the transpose of a matrix made from a cofactor. They write all the cofactor, they find all the cofactor, but when we write adjoint of a matrix, they forget to find the transpose. So teacher must tell the student to find cofactor by using proper sign and insist them to take transpose of a matrix made from the cofactor by giving more question for practice. In this way, we can remove this error. Again, sometimes simple errors to find the determinant. What students generally do by expanding this determinant using first row 2 into simply 6 3 ja 18 plus 2. Okay. So you can see here the error. We first multiply 1 into 2, then this, but student do in the reverse way, which is the wrong. And they also know this concept plus minus plus minus plus minus plus minus while solving. So your student is not even using this 2 into minus 1. Here you can use minus minus plus. One more mistake in determinant. Find the value of k such that the area of triangle with vertices given is 3 square unit. So yes, students know that area of triangle, they know the formula. So write that formula 1 by 2, x1, y1, 1, x2, y2, 1, x3, y3, 1. And they equate that simply equal to 3, which is wrong. And they simplify this and value they will get 7 by 6. So when the area of triangle is 3 square unit, means value of determinant may be plus 3 or minus 3. So it means we always write area of triangle is equal to, when area is given, plus minus 3, not only 3. So this error is common. One more question. To prove that a square minus 5a plus 7i equal to 0, and hence find a inverse. Question is to find the a inverse using this equation. Matrix A is given to them. The student what generally do, they prove this equation and they apply the formula to find the A inverse, that is 1 upon determinant A into adjoint A. So in this question, using formula is wrong working because question is A is given, then prove that this is equal to I, and hence means use this equation to find A inverse. So what is the remedy? We can find from here A inverse. How? 7i equal to 5a minus a square, and then multiplying by A inverse. So A inverse is 1 by 7, 5i minus a. So in this method, we can find here A inverse. What students generally do? They use the simple formula adjoint A upon determinant of A. One more error, common mistake while solving the linear equation. There are two matrices, A and B. So question is find the product of matrices A and B and hence solve the following system of equations. Means first find AB and use this product to find the solution of the equation. So generally what happened? Student find the product, but to solve the equation, they again use the formula A inverse equal to adjoint A upon determinant A. Means then they use the formula that X equal to A inverse. So this one is again not the correct approach because question is find the product. So first of all, we find this product A into B. Here we will use this sign of matrix. So this comes out to be 6, 0, 0, 6, 0, 6 means 6i. 6 is common and I. So when product of two matrices is I, then one is called the inverse of another. So from here, we can find that A inverse is 1 by 6 equal to B or B inverse equal to 1 by 6 into A. So we simply see what is given in the equation. So equations are written in the form of AX equal to C. A means already this matrix is given. So it means A inverse we will find from this product. So that is A inverse is 1 by 6 into B. So from here solution is that X is A inverse. X is A inverse into C. So what is A inverse? 1 by B, 1 by 6 into B into C. Then they can find. Next, error I have taken from continuity and differentiability. This one is again, maximum students do this error while solving the implicit equation. Y is an explicit function of X. For example, y raised to power 5 equal to X square. When students differentiate this function with respect to X on both sides, they simply write what? 5 into derivative of y raised to power 5, 5 into y raised to power 4 equal to and derivative of X square, that is 2X, which is wrong. So these mistakes students do unknowingly. Forget to write the term because y is a function of X. So what is the derivative of y raised to power 5? 5 into y raised to power 4 into dy by dx. This is just like function raised to power n. Means n into function raised to power n minus 1 into derivative of function. Clear? So this one is again the common mistake. One more mistake I have taken from derivative of parametric equation. When parametric functions are given, means x is a function of t, see in this question, and y is also function of t. So yes, students are able to find dx upon dt from here at cos t, and dy upon dt again they can find. And after that, dy by dx, they know the formula dy upon dt upon dx upon dt, that is tangent t. If we divide at sin t upon at cos t, so we will get tangent t. Now, question is find double derivative d square y upon dx square. So again, differentiating with respect to x. But student, what generally do? So they find left hand side, that is d square y upon dx square, and derivative of tangent t, that is secant square t. They only write secant square t, and again forget that we are differentiating this function with respect to x. So it means correct is you have to write derivative of tangent t, that is secant square t into dt by dx, meaning 1 upon dx upon dt. After that, substitute the value. So in this way, students do different types of common error. Maximum students do. So we can avoid by giving them more practice of such type of questions. One more problem I have taken from derivative. So this one is the common error, improper use of log during logarithmic differentiation. Students, what happen generally, use this formula log of a plus b is log a plus log b, which is the wrong property. Students should know the correct formula for logarithmic differentiation. Correct formula is log AB, means log A plus log B. So for example, if question is y equal to sine x raised to power x plus x raised to power x, so student what do? You're taking log on both sides. So log y equal to log of first function plus second function. So they simply open this first plus second. So this one is the end. So teachers should insist students to take first function as u and second as v, then find the derivative separately. So these are some of the examples which I have taken from +2 notebooks from the topic relation function, inverse trigonometric function, then continuity and differentiability. So thank you very much.